Hello, this is Swapnil Saurav, and I welcome you to my vlog channel. Today I'm going to talk about cloud computing. We'll talk about what is cloud computing. We'll get into a little bit of history of cloud computing. We'll talk about the different delivery models that we have like IaaS, PaaS, etc. Then we'll talk about deployment models like private cloud, public cloud, etc. We'll also talk about what are cloud data centers, and at the end, we'll talk about cloud stakeholders and their roles. So let's get into the details. The origin of cloud computing can be traced back as far as to 1961 when John McCarthy first conceived the idea. His vision was that computation should be arranged and organized as a public utility to lower the cost of computing, enhance reliability, and relieve users from owning and operating complicated computer or computing infrastructure. And since then, improvement in legacy technologies like virtualization, commodity, and grid computing has brought about the realization of the cloud computing paradigm. Cloud computing's flexibility and scalability has continued to enhance the agility and effectiveness of huge organizations, meeting reliability and the efficiency of large-scale applications. However, performance requirements remain a serious concern, and studies have shown that performance variability is a critical concern for cloud application providers. The reason for that is because it impacts a lot the end user's quality of experience. In this discussion, we are going to see in details what cloud computing is, cloud deployment models, delivery models, data centers, and more. So, what is cloud computing? It can be defined as a paradigm change in how computation is delivered and utilized. It is based on the idea that the processing of information can take place more effectively on large computing farms and storage systems accessible via the internet. It offers a set of technologies which enable provision of computational resources like compute and storage as a service via the internet, either on a pay-per-use or on-demand model. Two factors that contribute to the high adoption rate of the cloud are its ability to offer smooth, scalable, and elasticity to consumers without huge initial capital expenses. And second, it provides resources that can be metered so that the users are only billed for they have consumed. The two appeal factors have led to a drastic change in how IT, or that is the information technology departments, and application providers organize and manage IT services. So we'll talk about cloud delivery models. Depending on the abstraction level in which service is provided, public clouds have three main delivery models. These are infrastructure as a service, or we call it as IaaS. This involves fundamental computing resources like servers, network, and storage that are provided. Consumers are responsible for installing the operating system and can create arbitrary applications using application deployment or development tools of their choice. Various IaaS providers are available and they include Google Cloud Platform, Rackspace, Amazon EC2, and Microsoft Azure infrastructure. The second delivery model is a platform as a service, or PaaS. This model gives cloud users the ability to develop, deploy, and manage apps using app development tools, operating systems, APIs, and hardware supported by provider. The cloud user controls only the application, its architecture and hosting space configuration, but not the network, storage, servers, or even principal operating system. Among the most renowned PaaS offerings available today are Windows Azure, Google App Engine, and Amazon's Elastic Beanstalk. Software as a service. This occurs when end users start using finished applications accessible via various client devices over the internet. Together with the required software, OS, network, and hardware, the users can enjoy some measure of minimal customization, but they have limited control on the platform itself, its platform and underlying infrastructure. Some of the SaaS applications are Web2 applications like WordPress, LinkedIn, accounting systems like NetSuite, and CRM or customer relationship management softwares like ServiceNow. Now we'll talk about the deployment models. How are cloud infrastructures categorized? The classification can be based on either ownership or how they are managed. Five deployment models are available for cloud infrastructure so far, and they are 1. Private clouds. They are managed and used by individual entities. Some organizations adopt these clouds to acquire the benefits of cloud computing like scalability and flexibility, and at the same time having complete control on its infrastructure and security. Second is public clouds. These are infrastructures managed by an organization which leases them to third parties on a pay-per-use basis. Public clouds include RACSAC, Google Cloud Platform, and Microsoft Azure. The third model we're going to talk about is community model. They are used and shared by group or groups of people or organizations with a mutual interest, like North Carolina Education Cloud. The fourth is hybrid clouds. These are called hybrid because it involves a merger between two or more clouds. For instance, if a large organization which hosts its core IT infrastructure on a private or community clouds and wants to expand its capacity to meet a sudden surge in user demand, it can team up with at least a public cloud for that purpose. So it will do so by leasing public cloud resources, and hence the name hybrid clouds. The mechanism through which that happens is called cloud bursting. The fifth model is federated clouds. These are emerging type of clouds consisting of only public clouds, only private clouds, or both to provide end users with seemingly unlimited computing utility service. These clouds enable high interoperability and compatibility between different cloud services through open APIs that allows cloud users to distribute services based on offerings from various vendors or transfer data easily across platforms. An example of federated clouds is one established among numerous data centers owned by a single cloud provider. So now let's get into cloud data centers. What are cloud data centers? They can be referred to as the powerhouse of cloud computing, as they house several servers, communications, and storage systems needed for cloud computing. The servers, communications, and storage systems are co-located in the data centers because of their similar physical security, environmental, and maintenance requirements. Hence, the consolidation of such resources help in ensuring their effective utilization. Multiple applications cloud providers can share servers resources, thus avoiding underutilization and server stretch in data centers. The technology that makes consolidation and sharing better is called as virtualization technology. It provides performance isolation among co-located applications. Consolidation is cost efficient as it reduces capital and operational expenses and lowers energy consumption. Two mainstream platforms are available for realizing virtualization today, that are hypervisor based virtualization and container based virtualization. Hypervisor-based virtualization's example Zen or KVM and Hyper-5 imitates a machine hardware and allows instances of the imitation, that is virtual machines, to run on a different physical machine managed by a specialized operating system called the hypervisor. However, this approach is OS agnostic, since the guest operating system, which is the operating system installed on the VM, may be different from the host operating system, that is the operating system running on the physical host of the VM. Container-based virtualization does not emulate hardware platform but provides virtualization at the OS level to reduce performance and speed overhead of the hypervisor-based virtualization. It allows multiple isolated Linux environments or containers to share the base kernel of host operating system. Examples of container-based virtualization platforms are LXCs, Docker, and OpenVZ. Despite enjoying an increasing adoption, containers still cannot match VMs, which remain to be the common unit of cloud deployments because of the technology's maturity. VMs can be easily moved from one server to another to balance the load across the data center or merge workloads on fewer servers. VMs are also easy to manage software-defined units, and they facilitate the elasticity of the cloud. It is also possible to replicate them across servers, that is called as horizontal scaling, and their resource capacity such as CPU cores, and can be reduced or increased to address overload or underload situation, which we call it as vertical scaling. Infrastructure as a service data centers face a challenge of resource allocation. The concern is how to optimally share or distribute computing, storage, and network resources among a set of VMs in a way that tries to equally meet service objectives of both service providers as well as cloud providers. Now let's look at software defined infrastructures. There is a need for increased automation and programmability as the adoption of cloud computing for performing various roles grows. One such role is running mission critical performance sensitive applications like analytics, mobile services, IoT, Internet of Things, and machine to machine communication. It means that there is an increased demand for agility, performance, and energy efficiency. And that is what has led to the recent trend towards software defined infrastructures, called in short we call it as SDI. To facilitate automation, several studies have applied automatic computing techniques in a different aspect of managing current clouds like resource allocation, risk scheduling, and energy management. SDIs are anticipated to change the compute, storage, and network infrastructure to software defined and vigorously programmable entities. But what is SDI? A simple definition could be it is an infrastructure that is consistently transforming itself by properly exploiting heterogeneous capabilities and utilizing insights obtained from built-in deep monitoring, constantly honor consumer SLAs amidst providers' constraints such as cost and energy constraints. There are currently only a few SDI platforms or products available, but many of the technology aspects are still evolving. Even so, let's look at some of the components of SDIs. The first component we're going to talk about is called Software Defined Compute or SDC. SDC provides two roles. One, enhancing the programmability of existing virtualized compute resources like VMs, containers, and virtual CPUs. And second is the leveraging specialized processing units like GPUs or graphical processing units, FPGAs or field programmable gate arrays, and other accelerators. It decouples the provision of heterogeneous compute resources from existing hardware or operating system so that it is based on identified or discovered workload needs. Second component of SDI is software defined network or SDN. Its function is to the separation of control and management functions of the network infrastructure away from the hardware to the server. It does so to improve performance isolation, security, programmability, and effectiveness. By means of virtualization, it allows network resources to be transformed to virtual devices like links, endpoint, and switches that connects various virtual storage and compute instances. The third component of SDI is software defined storage SDS. It functions to manage huge data volumes by separating the control and management functions from the data storage system. Such separation helps in reducing management complexity and lower the cost of infrastructure. A SDI controller manages all SDI components by providing the control intelligence needed to meet workload requirements. It uses the classical map loop to consistently monitor the current state of SDI entity. The last topic is cloud stakeholders and their roles. Cloud stakeholders are usually grouped into one of the three roles depending on the service delivery models. The role of the cloud provider or IP infrastructure provider ranges from infrastructure provisioning in IaaS platforms and infrastructure provisioning in PaaS to the provision of the whole cloud stack like infrastructure, platforms, and applications in SaaS environment. Cloud users or SPs, we call them as service providers, are mostly found under the IaaS and PaaS model. They use the infrastructure and or the platform given by the cloud provider to host application services that are used by the end user. The interactions in terms of roles between the cloud stakeholders like cloud and service providers are administered by an official document known as the Service Level Agreement or SLA. The SLA describes what quality of service is expected and the legal agreements. A characteristic SLA constitute important elements like the service credits and service guarantees, outlines functional metrics, example response time, availability, and safety that a cloud provider needs to meet during the service agreement period. A service credit is a sum credited to a customer or put in place towards a future payment when the IP cannot meet the service guarantees. So, what we have seen so far is cloud computing is here to stay with us. It is what drives every IT operations today. Most cloud providers know what their role in providing hosting platform is, and they will strive to maintain their offering. My hope that this discussion has shed some light about cloud computing for you if you were not knowing these things. So with that, I end this vlog. Bye, take care.